Welcome to Quarantine Learning! Today we will go over exponential rules. I know there's a lot more than just what's here, but today we are going to focus on the product of powers, powers of a power, power of a product, and zero exponent. First, let's start off with power of powers. This is if you have the same base, and they each have exponents, you can just add the exponents together, like x to the third times x squared. 3 plus 2 is 5, so your final answer is x to the fifth. Power of a power. If you have x to the m, and it's in parentheses, raised to the nth power, you will multiply. It's kind of like distribution, but not fully. So this will be m times n. X to the fourth, in parentheses to the sixth, you just multiply 4 times 6, which is 24. Then we have the power of a product. This means that if something is in parentheses, this exponent outside, it gets distributed to every single thing that's on the inside of those parentheses. So this m goes to the x, x to the m, and the m goes to the y. So that should be y to the m. Whoop. All right, so in this example, we have xy to the fifth, the 5 goes to the x, and the 5 goes to the y. And then our zero exponent rule, if you have anything raised to the 0 power whatsoever, that just equals 1. X to the 0, doesn't matter what x equals, it's 1. To the 0 is 1. 1,287 raised to the 0 power is 1. Now, let's get to some of the examples on that worksheet. Here's number 3. We have 3 y squared times y, all in parentheses, squared. Now we know that if we have a power, that just means how many times it's multiplied by itself. So we can rewrite this as 3y squared times y times itself another time. So we have 2 of them. And then if we sit there and break everything down, we have 2 3's, a y squared and a y squared, and 2 more y's. And then if we break it down even further, y squared is y times y, and then we just have our other y's. So if we sat there and expanded this whole thing, we'd be sitting here writing out tons of y's, writing out all of our coefficients. 3 times 3 is 9, and how many y's do we have? We have 6 y's. But we know our exponent rules. They're going to help us out a whole lot. So let's go ahead and do this. Since we have a squared here, it will apply to everything inside our parentheses. So this 2 is going to go to that 3. So we're going to have 3 squared. It's also going to apply to this exponent right here. And remember, we're going to multiply them. So 2 times 2 is 4. And then it also goes to this y. So it goes to every single thing. And if there's nothing here, there's a 1. So 2 times 1 is just 2. 3 squared is 9. And then remember, when we have y times y, we can just add the exponents. 4 plus 2 is 6. So we have y to the 6th. Look at that. 9 times y to the 6th. 9 times y to the 6th. Exact same thing, a lot less work. Let's look at our number 6. This was a whole lot of stuff. We don't have any parentheses here. So what I did was I just put the coefficients together since they were all multiplied. And then I went ahead and I just put the variables together just as they were written. Z's first and then h's. Just because they're all multiplied together doesn't really matter a whole lot. And then I expanded it out. I drew 1 z, and then 4 more z's, and then 3 h's, and then 5 h's. Whew, that was a lot of work. 7 times 8 is 56. We had 5 z's total and 8 h's total. Or we can just apply our rule of exponents. 7 times 8 is 56. Z, remember if there's nothing here, there's a power of 1. So z to the first times z to the fourth, remember we just add 1 plus 4. So we have z to the fifth, and then h to the third, h to the fifth. They're multiplied, so we add 3 plus 5 is 8. And looky there, a lot less work, a lot less writing stuff out, and we get the exact same answer. Number 7. All right, this was another tough one, just because writing it all out, it was very long. 3 times b times 4 times b cubed, all cubed. So over here, if we expanded it out, we can write this whole thing in parentheses 3 times. And then bringing those coefficients, 3 times 3 times 3, 4 times 4 times 4, and then sitting there writing out all of the b's. I'm not even going to sit there and write out 3 more b's, 3, 3, 3, that many times. I'm just going to go ahead and use our exponent rules that we have to make it a lot easier on myself. Now you can do this in one of two ways. You can either simplify inside these parentheses first. So 3 times 4 is 12. And then b times b to the third, we add our exponents. Remember there's a 1 here. So we have b to the fourth. And then we have that cubed. Which means then we can distribute this 3 through. 12 to the third, b to the 4 times 3 is 12. All right, or if you didn't want to simplify inside the parentheses first, that's fine. You don't have to. You can distribute this 3 to every single thing inside first. So we have 3 raised to the third power times b raised to the third power times 4 raised to the third power times b raised to the 3 times 3 is 9. So this kind of looks like what we got out here. We have 3 3s, 3 4s, 3 b's, and then 3, 6, 9 b's over here. So we need to simplify this just a little bit more before we can go on. So 3 to the third times 4 to the third times b to the, we can go ahead really easily, just add these together. 9 plus 3 is 12. 3 times 4 is 12 to the third, and then b to the 12th. And then you can just use a calculator and figure out what this is right here, these numbers, because you can either leave them in simplified form, you can leave it like this in exponential form, you can simplify it to a number. Anyway, it's all good. Let's look at number 11. I know this was one of the rules that I didn't really go over. It's the division rule, but I wanted to show you this one because that exponent on the outside of the parentheses, it still has to be put through the parentheses when you have a fraction. So I wanted to show you how this works. Remember, anything raised to a power is how many times it's multiplied by itself. So if we have 9 to the 5th over 9 squared, 9 to the 5th over 9 squared, 9 to the 5th over 9 squared, 9 to the 5th over 9 squared. We have it 3 different times. Adding those, we have the same base, right, 9. Adding the exponents, 15 on top, 6 on bottom. And then the rule that we have is if you have a fraction, you just subtract top minus bottom. So 15 minus 6, so that gets us 9 to the 9th. So I just wanted to show you that is, we have to multiply this to both the top and bottom when we're using our exponential rules. So 5 times 3 is 15, 2 times 3 is 6. So this gets us the exact same thing that we got over here, just using our rules instead of having to write it out all over again. And then simplifying it, using that quotient rule, you just subtract 15 minus 6, so that's how we get our 9. All right, let's do one more example here real quick. This was number 12 on your worksheet. Here, we have a lot of g's inside our parentheses. So I can go ahead and write out 9, 2g squared, g to the third, 3 times, or you can simplify it in the parentheses first, which is kind of like what this is right here. We have 2, adding up all of our g's, 1 plus 2 plus 3, that's g to the sixth. And then we have that 3 different times. So 2 times 2 times 2 is 8, and then 6 plus 6 plus 6 is 18. Or we can go ahead, we can simplify it in the parentheses first, and then go ahead and use our exponent rule to just put that 3 on the outside the parentheses, distribute it through. Let's go ahead and do that. So we have our coefficient of 2. There's no other coefficients, so we don't have to multiply it by anything right now. And then we have all of our g's. Remember, g, if there's nothing there, there's a 1. Okay, so we have 1g times g squared times g to the third. So we have 1 plus 2 is 3, plus another 3 is 6. So 2g to the sixth raised to that third power. Now we distribute this 3. 2 raised to the third power, g to the, remember, if it's on the outside of the parentheses, we multiply, so g to the 18th. See how they're looking similar? And then 2 to the third, again, you can leave it like that, or we can simplify. 2 times 2 times 2 is 8, g to the 18th. And that's the same thing we got when we did it the long way. All right, guys, I hope this was super helpful for you, and I hope that you enjoyed hearing this with my voice instead of listening to just a recorded YouTube video. I wish you guys the best of luck. Email me if you have any questions. Have a great day.